I stopped making compost in summer completely, and my garden has never been healthier. Everyone tells you summer is prime composting season. Warm temperatures, active microbes, fast decomposition. But here's what they don't tell you. Fast isn't always better. I spent 3 years comparing winter compost to summer compost side by side, and the winter batch outperformed summer every single time. Different nutrient profile, better structure, fewer problems. Let me show you why slow and cold beats hot and fast. Summer composting has a dirty secret. You're losing nitrogen into the atmosphere. Those high temperatures everyone celebrates, they're burning off the most valuable nutrient your plants need. When your compost pile hits 140, 160 degrees Celsius in summer, you're creating the perfect conditions for nitrogen volatilization. This is a fancy term for nitrogen literally evaporating as ammonia gas. You can smell it sometimes, that sharp ammonia scent around hot compost piles. That smell is your fertilizer disappearing into the air. Studies from Cornell University's composting program found that hot composting can lose 20–40% of its initial nitrogen content through volatilization. You're working hard to build that pile, and almost half the nitrogen you added just leaves. Winter composting operates at 35 or 50 degrees. At these temperatures, nitrogen stays locked in the organic matter. It doesn't volatilize. What you put in stays in. By spring, you have compost with 30–50% more nitrogen content than summer compost that started with identical materials. I tested this myself. Same kitchen scraps, same carbon materials, same ratios. Summer pile in July, winter pile in January. Sent samples to a soil lab in April. The winter compost showed nitrogen levels of 2.8%. Summer compost was 1.9%. That's a massive difference when you're feeding plants. Think about it, you're essentially getting free fertilizer just by waiting through winter instead of rushing the process in summer. Here's something most composting guides completely ignore. The type of microbes matters as much as the speed. Summer's high temperatures favor bacteria. Bacteria break things down fast, but they create compost that's bacterially dominant. Winter's cold temperatures favor fungi. Fungi work slower, but they create fungally dominant compost, which is exactly what most vegetables, perennials, and established plants actually want. Fungi build soil structure. They create glomalin, a sticky protein that helps soil particles clump together into aggregates. This improves water retention, root penetration, and prevents compaction. Bacterial compost doesn't do this nearly as effectively. When you add fungal compost to your soil, you're literally building better soil architecture that lasts for years. Trees, shrubs, and perennial vegetables like asparagus and rhubarb specifically need fungal associations through mycorrhizae. When you add fungally dominant winter compost around these plants, you're inoculating your soil with the exact biology they evolved to work with. It's like speaking their native language instead of trying to communicate through a translator. I noticed this first with my tomatoes. Summer compost gave me fast early growth, but plants that struggled mid-season with diseases and nutrient deficiencies. Winter compost produced slower starts, but plants that stayed healthy all season resisted disease better and produced right up until frost. The fungal networks were supporting them underground in ways I couldn't see but could definitely measure in my harvest weight. Summer compost creates a weed bomb if you're not careful. Winter compost solves this problem automatically. Weed seeds need sustained temperatures above 130 degrees Celsius for several days to be killed. In summer, if your pile doesn't heat evenly or you don't turn it properly, you're preserving viable weed seeds throughout. I learned this the hard way when I spread summer compost on a flower bed and got a carpet of chickweed and crabgrass 2 weeks later. I basically fertilized weeds I was trying to avoid. Winter composting never gets hot enough to kill seeds quickly, but here's the trick. It freezes them. Multiple freeze-thaw cycles destroy seed viability through a completely different mechanism. Ice crystals form inside the seed, rupturing cell walls. Each freeze-thaw cycle damages more seeds. It's mechanical destruction rather than thermal killing. Research from the University of Alaska showed that weed seeds exposed to 5 freeze-thaw cycles had germination rates drop by 60–90% depending on species. Winter naturally provides 20 to 40 freeze-thaw cycles in most climates. Your pile is going through this process automatically every time temperature crosses the freezing point, which happens almost daily in many regions during winter months. My winter compost has virtually no weed pressure. I spread it liberally without worrying about creating more work for myself later. Last spring, I put 3 inches of winter compost on my vegetable beds and didn't pull a single weed from compost germination. Compare that to summer compost, where I was weeding constantly from my own compost contamination. Food safety is a real concern with compost, especially if you're growing vegetables. Summer's heat should kill pathogens, but only if every part of your pile reaches 140 degrees Fahrenheit for 3 days. Most backyard piles have cold spots that never reach that temperature. Winter uses a different sterilization method: time and competition. Pathogens like E. coli and Salmonella don't survive well in cold environments with low available water. Ice doesn't count as available water from a microbial perspective. They also can't compete with the slow-growing fungi and cold-adapted bacteria that dominate winter piles. It's biological warfare, and the pathogens lose. Studies on pathogen survival show that E. coli populations decline by 99% after 60 days in winter composting conditions, even without high temperatures. The combination of cold, time, and microbial competition does the work that heat does in summer, just through a different pathway. Some researchers argue it's actually more reliable because you don't need to worry about temperature distribution throughout the pile. I use winter compost on my vegetable beds without any concerns. The 4–6 month cold process gives me confidence that pathogens aren't an issue. I'm spreading it directly around lettuce, carrots, and other crops I eat raw, and I've never had any food safety problems. The long cold exposure period is more foolproof than trying to maintain perfect hot composting temperatures. Summer composting attracts flies, rodents, raccoons, and creates odor problems that annoy neighbors. Winter composting has none of these issues. Flies can't reproduce below 50 degrees Celsius. The common fruit flies and house flies that swarm summer compost piles simply aren't active in winter. Their life cycle stops. You can leave banana peels and rotting vegetables exposed and you won't see a single fly. Rodents are less active and less interested in frozen food scraps. They're focused on finding shelter and stored seeds, not digging through frozen compost. Raccoons and opossums are in semi-hibernation, or focused on other food sources that are easier to access. Odor is primarily caused by anaerobic bacteria producing sulfur compounds and organic acids. These bacteria work best in warm, wet conditions. Winter's cold temperatures slow their activity to nearly nothing. Even if your pile gets compacted or too wet, you won't get that rotten egg smell that plagues summer piles. The worst you'll get is a slight sour smell that disappears as soon as temperatures rise. I keep my compost bin 15 feet from my back door. In summer, I had to move it to the far corner of the property because of smell and flies. My neighbor actually complained once about the odor drifting into her yard during a heat wave. In winter, I could keep it on my porch if I wanted to. Zero odor, zero pests, zero complaints. I can open the lid to add scraps, and there's no cloud of fruit flies attacking me. No maggots crawling around, just peaceful decomposition happening slowly. Summer composting requires constant moisture monitoring. Too dry and decomposition stops. Too wet and you create anaerobic sludge. You're adding water during dry spells with a hose or watering can, then dealing with rainstorms that waterlog everything and create stinking messes. Winter handles moisture automatically through snow and ice. Snow acts as a slow-release water source. As temperatures fluctuate above and below freezing throughout the day and season, snow melts gradually into the pile, providing consistent moisture without drowning it. You're not adding water, you're not managing wet-dry cycles. Nature does it for you on a perfect schedule. Ice formation also improves compost structure. When water freezes, it expands, creating spaces in your compost. When it thaws, those spaces improve aeration naturally. You're getting natural turning and aeration without lifting a pitchfork. Every freeze-thaw cycle is essentially a passive turning of your pile, redistributing materials and creating air pockets. I don't touch my winter pile for moisture management. I add materials, cover it with a lid or tarp to keep excess rain and snow out, and walk away. By spring, when I open it up, the moisture content is perfect without any intervention. It feels like a wrung-out sponge, which is exactly what you want. Compare this to summer, where I'm checking moisture weekly and adjusting constantly. Summer compost is ready in 4 to 8 weeks if you're hot composting. That sounds great until you realize you need to process materials constantly through the growing season when you're busy planting, weeding, harvesting, dealing with pests, and trying to keep everything alive during heat waves. Winter gives you a 4 to 6 month processing window when you have nothing else to do in the garden. You're collecting materials slowly through winter, adding them to the pile whenever convenient, and letting time do the work. No pressure, no turning schedule, no temperature monitoring, no rushing to get it finished. The garden is dormant, you're dormant, and the compost is slowly processing in the background. By the time spring arrives and you're ready to plant, you have finished compost waiting for you. The timing is perfect. You start collecting materials in November, keep adding through winter, and by late March or early April, you have rich finished compost exactly when you need it for spring planting. Summer compost finishes mid-season when you don't necessarily need it, or you're scrambling to finish a batch before spring and cutting corners on the process. Here's how I actually do this, and it's embarrassingly simple. In October, I build a 4 or 4 foot pile in a corner of my yard with fallen leaves as the base layer, kitchen scraps accumulated over a few weeks, and garden waste from cutting back perennials. I add materials throughout winter whenever I have them, usually kitchen scraps every few days and more leaves as I collect them from neighbors. I don't turn it, I don't monitor temperature. I might add a tarp over the top if we're getting excessive rain that would waterlog it, but usually I don't even bother with that. By April, I have 3 to 4 cubic feet of finished compost. Dark brown to black, crumbly texture, smells like forest floor, nutrient-rich and ready to use. I spread it on my garden beds 2 weeks before planting, work it into the top few inches of soil, and watch my plants thrive. My soil structure improves every single year. Clay breaks up easier, sandy soil holds water better. Plants are healthier with better disease resistance. I spend less money on fertilizer because the compost is doing that work. Compare this to my old summer method, building piles in June, turning them weekly in 90-degree of heat while fighting swarms of flies, managing moisture constantly, adding water then draining water, losing half my nitrogen to the atmosphere, and getting finished compost in August when I'm too busy harvesting and preserving food to properly use it. Winter composting removed all that stress and gave me better results. Winter composting works with nature instead of trying to speed it up artificially. You get better nutrient retention because nitrogen isn't volatilizing in high heat. You get better microbial diversity with fungal dominance that builds long-term soil structure. You get fewer weeds because freeze-thaw cycles destroy seed viability. You have no pests, no smell, no neighbor complaints. Moisture manages itself through natural snowmelt and ice formation. And it fits perfectly into your garden calendar, processing while you rest and ready exactly when you need it in spring. Next time someone tells you composting stops in winter, or that you need to bring your pile inside or heat it artificially, you'll know they're missing the whole picture. Cold and slow isn't a bug in the system, it's a feature. It's actually the superior method for most home gardeners who want great compost without the summer hassle. Want to see what my winter compost looks like after 6 months of cold processing? I made a follow-up video showing the finished product and exactly how I use it in the spring garden.